Welcome to video 8 in series 3, and in this video I'll go over raycasting. That's what you use to detect stuff. To start with, I'll make 3 cubes, so 3D object cube. I'll just reset the position and just move it a little bit in front, move it up. I'm just using control here to keep the snapping. Duplicate another time, just put another one here. Each one has a unique name. So what I'm going to do is I'm going to fire a raycast from the first person character out forwards from it and let it touch the cubes, and then I'll use information from the raycast and play a message down here that shows the name of the cube, and the name is of course the name of the game object, or the transform as it might be called. Alright, so if I play the game, you can see that the first person character, there you go, that's it. It rotates with the mouse, right? So it's perfect for firing a raycast out of, a detection sensor basically. And that raycast will give back a wealth of information if I choose to have that happen. So what I'm going to do is I'm just going to, when I left click, I'll fire a raycast, it'll hit the cube, and then I'll get some information down here, well, the name of the cube, okay? And the reason why I've attached this script to the first person character is out of convenience. So I am going to fire this ray from this transform's position, and I'm going to fire it forward, so it'll always be in the direction of the blue axis that you see there. It's a local axis. So by doing that, it'll always fire right out of the center of the camera, will seem to be, and that's exactly the behavior that I'm after. Okay, so I'll go ahead and edit the shoot script to do exactly that. I'm going to add a new variable here, and maybe 2 new variables. The first one is private raycast hit, and I'll just call it hit. This is what will contain the information about what was hit by the raycast. And then the next thing I'll have is private float range. And I'll say that the range of the raycast will be 300. At the moment it's nothing, it's just a float, but that's what I'm going to use it for. Here I'll just get rid of this, not necessary. I'll comment out the debug log statement. Now there's a lot of information about raycasts. I strongly recommend that you always go and read the scripting reference so you understand a little bit more. I am going to use there's quite a few different ways you can write it. There's quite a few different configurations for the arguments, and I'm going to use one particular one that looks like this. Actually, it is this one. It's a raycast. It requires an origin, direction. It'll give out some hit info and a range for it, a max distance. So there's quite a few examples here to help you understand how to use it. Since I already know, I will go ahead and use it. So I only want something to happen if the raycast hits something. So I have to put here if raycast, if physics rather, if physics dot raycast, and then within that raycast, now there's 16 different configurations, different argument sets that it can take, and the one I'm interested in is number 12. So if I go to it, there we go. It requires an origin, a direction, I will take out some information, and the range for it as well. So the origin is going to be transform, a small t, transform dot position. So what is this transform? Transform is a I always call it cache, but people complain and tell me it's pronounced cached. So it's a pre-cached variable for this transform. Whatever the script is attached to, it will refer to this transform. That small t transform there is talking about this because this script is attached to this game object. If I had attached the script to like a cube instead, then it will be talking about the transform of the game object that the script is attached to. Okay? And I will make this very slightly more efficient in just a moment. For now, I'll just use transform.position. Okay, and then I will use transform.forwards. Because this game object is set up perfectly, the blue axis was actually the forward axis, so it works. Transform.forward, and then out hit, so it'll give me back information of what was hit in the hit variable. And then the range, so the distance it's going to fire, and that's enough. I can also use something else called layers to make the raycast only hit game objects of a specific layer, but I'll talk about that later in another video. Okay, and if it does hit something, what I will do is debug.log hit.transform.name. So that's how you can access the name. You can do it through transform or game object, but the hit variable doesn't store an immediate reference to the game object. It has, though, one to the transform, and then so you can access the name. Actually, I should show you something. So when you press the full stop there, you can see all of the bits of information that you can pull from hit. So it is a lot like the exact hit point, exactly where the raycast hit is even recorded, and this is very important for effects. You would like instantiate or pool, use a effect from a pool and make it appear at the exact hit point, like sparks and stuff. So there's quite a few things you can get out of it. Anyway, the one I was interested in was transform.name, and okay. And it should work straight away. So I'll go ahead, jump in, and hit play. Oops, I pressed that twice. And why don't I walk up to the cube, left click, and there you go. It's hitting cube 1, and you can see that was cube 1 on the left. Now this is cube 2 on the right, and cube directly in front. So let me fire at this one. There you go, cube. Right now, well, you can't really see the raycast, so how about I put in a debug.drawArray, debug.drawArray, and you pass in the arguments in a similar manner. So transform.position, then transform.forwards. You can also set the color of it, so use a capital C, color.green, and duration, how long you want it to be there for, so you can see, you can spend a few moments figuring out where it was. So I'll put in 3 seconds. Okay, and I'll just save that, go ahead and run it again. And I can show you that if I shoot at the floor, there you go, it'll also give the name of the floor. How about I zoom in, click on the first person character, and I just minimize this a bit, it's not so important. You can see that the ray is drawn exactly in the orientation of that forwards axis, the Z axis. So it is behaving as expected, the ray is drawing correctly, and all the behavior is fine. Now I'll show you something else. I find that when you're like your player, whatever starts to get more complicated, and if you're not using layers to limit what the raycast can touch, then you may have like a collider on your player and the ray will hit that. So I forgot to mention something. A ray hits something that has a collider. If the object doesn't have a collider, so say for example, if this cube on the right, let me try it out. If I turn off the collider and I try to fire at it, it's just going right through. It's not touching the box because the collider is disabled. The ray requires that whatever it's supposed to touch has a collider on it, okay? So if there's no collider, it'll then touch the next thing that has a collider, and if nothing has, and that means it's shooting off into space, then nothing happens. Okay, so what was I going to show you? I was going to show you about if, for example, the raycast hits a collider that's attached to the players of any kind, then in that case what I need to do is to offset the position relative to the transform itself. So I would use, instead of transform.position, I would use transform.transformPoint, this one right here, and then define the vector 3 from which that should be done. So for example, if it's some sort of set of colliders that are on the player and I don't want the raycast to actually accidentally hit them, and also I don't want to use layers to limit what the raycast can hit, then in that case it becomes necessary to use transform point. So for example, I can set it to fire 1 meter in front of the actual position of the transform. So I'll do that in both places. So transform point and set in the coordinates. Okay, and save that. And now you'll see that the debug.drawArray will appear 1 meter in front instead. So let me just select that, come back here, there you go. You can see it appearing 1 meter in front. And it also works again. So if it's the cube directly in front, yep, it gets struck. Of course, if you get too close, then you will find that the raycast will simply be fired too far forward and not detect the collider on the cube. But then in that case, it's usually not that big a deal. Like, you have to get really close in order for that to happen. But anyhow, I thought I should just show you that just in case you come to a situation like that, and you probably will. Alright, so now I mentioned that I was going to make it a bit more efficient in terms of the usage of the term transform here. So the normal thing that I normally do is to just make a reference to it. So I'll just call it this variable myTransform. And then I'll make up my own function here, call it void set initial references and set myTransform to equal transform. And this is just very slightly more efficient than just calling transform directly like that. It's not really noticeable. In a case like this, you don't actually have to. I just do it by habit, and of course I need to call it in start so that the reference is established, and now I can use it here without having errors happen. So I'll just replace all of these instances of transform with myTransform. Okay, and I'll just put that here too. Okay, and I'll save that. Oh, sorry, whoops, hit.transform, that is correct. And there we go. So now it'll fire from the cached variable. It knows that that's the transform. So if you were doing like a loop and you had 1,000 iterations for some reason, and you were accessing the small transform, this one, 1,000 times, well, this having this set up like this is slightly more efficient than just accessing directly. Okay, and you can check that sort of stuff with the inbuilt Unity profiler. So if you add a tab, profiler, you can see that kind of stuff. You can see your CPU usage as you're running your game. And the behaviors that you write, they generally fall under the behavior update portion. Alright, so there you can see the script running. Alright, so I'll just change that back and set it back to the scene view. And just, oh, sorry, I forgot to unpause it there. Whenever you click in the profiler, it'll automatically pause. So let me just unpause that, go back, and I'll find that it's all working just fine. Okay, so that's enough for this video. So you've seen how to use raycasting, and it's the most common method used for detecting stuff in a game. Alright, so thanks for watching, and see you in the next video.